Then my
Okay.
rules are yours. So yours.
Now, next week on yes, I did. Thank you. Next week we are going to work on section 2 in chapter 5 for a couple of days. We're going to kind of lead into that a little bit today. Section 3 is kind of a culmination of sections 1 and 2 together. Kind of the results we learn in section 2 kind of comes together with some formulas and some things to work on in section 3. And then we'll do a quiz on Thursday. And I don't think we have school next Friday, right? Because there's parent-teacher conferences, I think, next week. And so I think there's no school Friday. So we'll wrap that up and with a quiz over those things on Friday. By the end of the term, we'll have that quiz. We'll have the quiz you took yesterday is not graded yet. That will get in at some point here tonight or tomorrow. And then we'll have another gateway test. You can tell on that sheet, that assignment sheet I gave you, there's another gateway test. And I don't know, there won't be a whole lot of other grades probably by the end of the term. I mean, I don't know. We'll see. We'll come up with. There may be another thing that we do, group paper, which I'll talk more about what that is. That may happen before the end of the term as well.
So the other gateway is in this term?
The other gateway, I haven't really penciled it out yet, but it'll be close. Yeah, it'll be close. It may come a little bit towards the end of the term, and if it does, because remember the way we did it is you had opportunities to pass it if you didn't pass it the first time. And that may carry over into the next term. And that's happened to us before, and so I'll explain how that would work. Typically, the gateway test will count in one of the terms for everybody. And I think what I've done is if it does carry over that way, that I will also put it in the other term if it helps your grade. If it doesn't, you know what I mean? So, if you never pass it, and you finally end up taking a 10 out of 30, well, I'll just put it, it's going to go in one of the terms for sure, and which would be probably the term you took it in, passed it in, so that would be the last term. Unless you dropped at the term, then it would be in the previous term, but clearly 10 out of 30 is probably not going to help your grade. But if you pass it right away, got 30 out of 30, and it was during this term, it'll go in this term, and then I'll also put it in as a grade to start. Done that before too. Okay, so anyway, we'll see where we're at when we get to that. That's probably what will happen. Okay, so for those of you listening at home, we are now about to go over the LH packet, which I put a link if you were at home and didn't pick up a copy of that. Here's a link for this packet that they have just been working on the website. Okay, and here is that packet. And I wanted to talk about number 6 and number 7. Did you have any concerns about, especially number 7? And did you notice anything different about 6 and 7? They used y. Now, that probably didn't concern you too much because the other day we said if you did the integral of u squared or t squared or x squared, it didn't matter, right? Remember when we talked about that? And that's true. However, when we were doing that example, x squared, t squared, u squared, z squared, those were the input variables. Look at your axes here. X is the input and y is the output. And we gave the function as f of y. That is a different story. Okay? Now 6 may not have been as confusing as 7. 6 you might have just... Matter of fact, I would bet good money, unless you talk to somebody in the other class, so that's why I'm not going to bet, but I would not be surprised if the have y minus 2 quantity squared dy from 0 to what? That's wrong. It would be from 0 to 2. Since you were giving that in terms of the output variable, we would do 0 to. Now, we had not talked about that yet. And to be honest, it's not going to be a concern of ours here in Chapter 5. Later on, we will work with that quite extensively. But for right now, that's not going to be an issue. Now, you could have turned this into one that we're used to, because it does have the, remember, because we said the area is between the curve and the x-axis, right? Look at 7. See, that's the issue I was wondering if you would have with 7. 7 doesn't have the area connected to the x-axis. See? So that is not one we could do the way we've been doing them. We'll get to 7 in a minute. So on this one, what we could have done, what's another name for f of y? Let me back up a minute. What about this one over here that said f of x equals 4 minus x squared? What's another name for f of x? Y. What's another name for f of y? X. This equation is x equals y minus 2 squared. Now, if you notice, this is a parabola on its side, shifted 2 up, and it's the bottom half of the parabola. Did you notice that? It's the bottom half of a sideways parabola. Now, if I square root both sides, normally you do plus or minus, but since I just told you it was the bottom half, which do we want? The negative, because it's the bottom half. And now let's add 2 to both sides. We get y equals negative square root of x plus 2. That's this function. If you want to do the area using our normal way of doing it, then you should have set up this integral, negative square root of x plus 2 dx from what to what? 0 to 4. Now again, we will get into that much more later on. Now take your calculators out right now if you would. Jot those down. Jot those 2 integrals down if you would real quick, because I'm going to have to leave this screen. So you probably already have the other one down, but jot down that second one that we have here. Okay? Now, I am saying to you that those 2 integrals represent the same piece of area, right? Those are 2 different ways of writing that same piece of area. So let's go to our calculator, and I have made Jacob Olson the presenter. You're welcome. So go onto your calculator screen. Everybody do this, but Jacob, go on your calculator screen and go into the template where you would do derivative, and there is the integral right here. Okay, he's already got his thing on it. That's the integral that we're going to grab. Go ahead and put in the first one we had, 0 to 2 of y minus 2 squared. Now the calculator doesn't care if he puts a y right now, or a t, or a z, or an x, or whatever. It doesn't care. But I think it's probably a good habit to write in the same one as what's in your calculator. Go ahead and hit enter. And if you haven't used the integral before, there you go. That shaded piece of area is 8/3. And if you kind of look at it, maybe think of like a triangle or something, it seems pretty reasonable. Now I want you to go ahead and type in the other one that we did. The 0 to 4 with the negative 0 to 4, negative root x plus 2. And we get 8/3. Amazing. Okay. That wasn't that exciting? Okay. You know what? Maybe you won't find Monday that exciting either. I should not get too excited. But anyway. So 2 different ways. Write that same thing. All right. Let's go back to question 7 then. And so question 7, now there wouldn't be 2 ways to write this one because it's not the area is not bounded down there on the x-axis. So that would be a different area. But then, so now, as you've probably already fixed yours, you put y cubed dy, and then what would be your limits? 0 to 2. This should have been 0 to 2. Okay? It's up along the y-axis. All right. So again, later on we'll get into more about why that is and some issues with that. But hopefully, as you look at it, you say, hey, yeah, that kind of makes sense. I mean, when we have those kinds of things. All right. The other thing I wanted to talk about was that I thought was kind of interesting was number 20 down here. And hopefully you recognize this graph. We talked about the other day. What is 19 and 20? What are those graphs? Half circles, right? Those are half circles. And what I thought was kind of neat about this, and I guess what's neat about it is that our calculators can actually do it, right? Now, you would do it because you just know it's a half circle, and so you know that answer's got to be what? It's got to be 1/2 pi r squared, right? That's a circle, radius r, half of it. It's got to be that. But let's go back to our calculator. So Jacob, go ahead and type this. Go ahead and type this, and everybody else go ahead and try it if you want. Go ahead and type this integral with the r in it. See, this is what the CAS version of the calculator can do that the non-CAS version can't do. It couldn't handle these r's as constants in here. Okay, it can only work with numerical values. Okay? So we'll come back to the calculator here. Now, and Jacob's got it up here. Notice it did it kind of weird, didn't it? It did the absolute value of r. It's because it doesn't know r could be negative, and we don't want r to be negative, and so forth. So go ahead and grab that again, Jacob. And if this happens to you, you get a situation like this, and you're like, well, the bars are there because the calculator is concerned that r might be negative. So go ahead and do your vertical bar right now.
Our calculator's expressing concern.
They're concerned. Yeah, the calculator is concerned. And then put r greater than 0. So if you run into one of those and you're like, oh, hey, they told me the problem that r is greater than 0, you can just actually put that in, hit enter, and then you get your 1/2 pi r squared. Okay? All right. So that's kind of neat because there it is. The calculator is able to calculate that, and it's the circle formula. It's only half a circle, so Jacob, grab it one more time and then stick a 2 in front of that since it's half circle, right? And so just put a 2 in front of that function, and then hit enter, and then you get your full circle, right? And it's here. And we will learn about how we could do that, how we'd be able to find that actual formula. All right. On the board here, I've got the this stuff here about. I don't think I ever wrote it up on the board. We talked about it. The definite integral, the parts of it. The A and the B are called the limits of integration. I don't use that term very often because it kind of confuses with the word limit that we've used in other ways. So I usually don't say that much. The integrand, that's the function that's inside the integral. Okay, that's a term that you might see. All right. What I'd like you to do now is or on your calculators, I'd like you to open up that document that you had to do yesterday during class, and we're gonna take a look at that a little bit. All right, Jacob, go ahead and grab the point B and slide it over just a little bit to the right of A. All right, yeah, right in there is fine. Okay, now the questions in the packet yesterday were mostly about when the f function is here, what's the area? Is it negative or this and that? And a lot of those questions were kind of repeats. I mean, they were getting after the same kind of stuff. They were getting about as you move B to this direction. So I want to kind of go through, and not specifically those questions that were on there, but now that you had a chance to go through that a little bit, I want to do that as well. And they hinted at it a little bit. I don't know if they ever really talked about it. Did they ever talk in there about area function? Was that term ever in there that you remember? Okay. I want to talk about area as a function. And the reason for that is, think about what we did with slope. I mean, because to be honest with you, this integral, and I've said it in many different forms, that they're kind of connected. The definite integral here is just a number. It's just a piece of area, right? So when you have a definite integral, understand that that's just a number. Much like f prime of 3 is just a number. Now, for us in the beginning, it meant slope at 3, right? The slope of a curve at 3, instantaneous rate of change, slope of the tangent line. We come to find out, as we went through the semester, that that means other things too. That might mean the velocity of the car at 3 o'clock. It might mean the rate of change of the cost of the textbooks when you've made 300. This might mean how fast the sand is piling up on the pile at 3 minutes or whatever, right? We came to find out that that number, f prime of 3, could mean a lot of different things. Well, that's the same thing that's going to be true with the integral. It's a number, but it's going to come to mean more than just a piece of area. Just like f prime of 3 came to mean more than just the slope at a point. Okay, so that's one thing. So we're going to talk about, in this case, I want to start here by talking about this gray area as a function. Now, a function needs an input and an output. And for every input, finish the sentence. There's only one output to be a function. For any input, there can only be one output. So here's going to be our function. We're going to let the left endpoint A stay put. A is going to stay over there at -3, so that's not going to move. But we're going to, Jacob here in a minute is going to take the right endpoint and he's going to change, he's going to slide that to the right. And it's going to change, right, every time he slides it a little bit, he's at a new x value. That's going to be our input. The right endpoint is going to be our input. And the output's going to be the area. So for any right endpoint, how many areas can you have? Only one. So it's a function, right? So I'm going to keep track of this here. I'm going to call that A sub f. I'm going to call that A sub f, meaning the area under function f. Okay? And so we're going to keep track here of kind of any connections that we see between this function and the area. And it's kind of like what they were asking you in that worksheet yesterday. Okay? So we're going to keep track of that. All right. So go ahead and go back there a little bit, Jacob, to where you were at the beginning. All right. So right now we've got a piece of area. And what can you tell me about that piece of area? It's small. What else? And it's negative. Why is it negative? Because it's below the x-axis. Because f is below the x-axis. Because f is negative, right? Okay. Now, as he slides point B to the right, what's happening to the area? Okay, stop right there. It's getting more negative. What's that mean? What's a better word for that? More area, but one word that would better describe more negative. Decreasing, right? More negative, -3, -4, -5, -6, decreasing. Now, why is it getting more negative? Because where's f? Below the x-axis. So, since f is negative, right? Since f is below the x-axis, what's the area doing? We're talking about as we move from left to right, as we move our input, remember our input is the right endpoint. As we move to the right, our area is decreasing because we're picking up more and more negative area. So keep sliding it, keep sliding it. We're still picking up negative areas, so our area is going down, going down, going down, more negative, whoop, right there. What is now going to happen? Slide it a little to the right. Little to the right. What's happening? Stop. What's happened to our area? It's still negative, right? Because we got more negative area than we have positive area. But it is still, this is really important stuff. It's too bad we got to do it on a Friday on an early dismissal, right? When we're already thinking about our snow day and some snow day. Too bad this isn't Wednesday. This could be a Thursday, Friday snow day. Or Sunday. All right. These are great. Yeah, Saturday, Sunday, we snowed in by Sunday night. Everything will be clear. We'll be good to go Monday. Anyway, yeah, I know. So, but anyway, this is good stuff. I wish this was Monday, but this way Daniel gets in on a little bit of it. Right now, what happened to F? F was negative. It's now positive. F is now positive. And as soon as F turned positive, we started picking up what? Positive area. Well, the area was negative. We're starting to pick up some positive. The total area is still negative, right? But our area graphs, or if we were going to graph this, if we were graphing this right now, right? Because it's a function, so we can graph it. If we were graphing our area is starting to do what? Increase. So our area is now starting to increase once F turned into the positive. So we keep going, and we keep going, and we keep going. And of course, it's still a positive this whole time, so our area is going to keep increasing. At some point, it's going to turn positive, right? About there, right? Now those two areas are equal, so they cancel each other out. We got 0, and now we're getting positive area. Okay, slide on back there again, Jacob. And now come to the right. Come to the right. Now, right there when F was 0, something kind of interesting happened, right? Our area was going down, we said, and then our area started going up. What do we got? Our area had a local minimum. Okay, now I should, I forgot we're recording this. Should put somebody in charge of this. Anybody want to run this thing?
I will.
Okay, now, can you see it from back here? All right. Here, go in and make that a little more of a negative right there for the people listening at home. Just tap somewhere, and there it comes.
Good morning.
Okay.
I have a few weather-related
Just make that a
announcements and
negative.
cancellations prior to leaving for lunch today. The Kearney High School debate students will not be going to the Millard North Debate Tournament tomorrow. Once again, the Kearney High School debate students will not be going to
Hey,
the
change that
Millard
to black.
North Debate Tournament tomorrow. The
Jump right
set and props workday for Little Women has been canceled for tomorrow. The set and props workday for Little Women has been canceled for tomorrow.
Okay.
After school detention will be tonight from 1:55 to 2:55 in room 15. Once again, after school detention will be held tonight in room 15 from 1:55 until 2:55. The Kearney High School boys basketball Saturday with the Bearcats youth basketball clinic scheduled for
Write your
tomorrow
name right.
has been canceled. Once again, the Kearney High School boys basketball Saturday with the Bearcats youth basketball clinic scheduled for tomorrow has been canceled. The swimming and diving invitational scheduled for tomorrow has been canceled. The swimming and diving invitational scheduled for tomorrow has been canceled. And finally, the boys junior varsity and varsity games scheduled for tomorrow versus Omaha Central have been postponed to a later date yet to be announced. Once again, the boys and girls JV and varsity games scheduled for tomorrow versus Omaha Central have been postponed to a later date yet to be announced. Thank you.
Yeah. No, I knew there was no way they would go. If it just rained hard, they probably would. Yeah, if it rained hard, they would. They are still. Okay. All right. That's me. Now, and now, Ryan, here's. Can you see that thing right down there? That's when we want to come to this.
Okay.
And then when we want to go back to the calculator, it's way over
I
here.
can't see that one over there.
Next to Google
Do you
Chrome.
see that?
Yeah.
Next to Google Chrome.
It's one of those little buttons down there.
Yeah, go ahead and go there right now.
Which one is it?
That one.
Right.
No,
Right.
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 No,
Yeah.
there you go. Yes.
Click it.
Yeah. Okay. Good. All right. Now, maybe this would have been better by now. All right. No, this will be fine. So we had a local minimum. Now, this might have been a bad idea. Starting to look familiar? That'd be a good name.
We call it the
The table. We'll call it the table. We want to call it something different this time. Yes.
Won't it all change if it goes past that though?
That we're going to save because on a day like today, that is just. Zach asked, what happens if that right endpoint goes to the other side? I don't even think we want to go there yet. Turns out, no, it won't change. But thinking about why it won't change, I just want to get into it. It's great. It hurts. It'll hurt. Now, listen. We know in the chart there's more stuff. Okay, go back. This would be enough to think about, I think, right now. So Jacob, going back. All right, now. Okay. Focus in again. Right now we've got negative area. F, the red graph is F. F is negative right now. But what else is F right now? Decreasing. Right? F is decreasing right now. Now, because we've already recognized this as in chart connections, what do you suppose should go in the area row? Concave down, right? So let's see. So right now, the red graph is decreasing. We've got a piece of negative area there right now. Okay? Jacob, I want you to take point B, and I want you to just move it like one step to the right. Stop. Now what happened? We just picked up a chunk, and that'll be the technical term we use. Stop. We picked up a chunk of negative area, which means the area graph went down, right? Of course, we already knew that. We knew the area graph was going down. Okay, take one more step to the right. That's another technical term, step. Right? He just picked up another chunk of negative area. How did that chunk compare to the previous chunk?
It's a bigger chunk.
It's a bigger chunk. Because the F graph was going down, as we move to the right, we're picking up bigger and bigger chunks of negative area, which means the area graph's not only going down, but it's going down at a... Okay, Ryan, switch me over.
How do I get this? I know that the mouse is moving.
Tap it. Just tap on it. There you go.
Come on.
Okay? Not only is it going down, not only is our area graph going down, but we're picking up bigger and bigger chunks of negative area. So it's decreasing at a... Oh yeah, it's decreasing at an increasing rate. That's concave down. Okay, switch me back.
Right.
Right,
No,
right. There.
Yeah.
No.
Yep.
All right. Now, keep going, Jacob. And now we're picking up bigger chunks of negative, bigger chunks of negative, bigger chunks of negative until stop. Now what? Now keep going. Okay, what are you going back? Going back. Okay, now look what's up. Stop. F is now what? F. What's F doing right now? F. Okay, switch me back, Ryan.
Yeah.
Okay, F is now increasing, and so what is the area graph doing? What we were still picking up chunks of negative area, but what? Smaller chunks of negative area. So the area graph, look, the area graph was then starting to do that. Didn't it switch concavity? Because it was still going down, because we were still, okay, switch me back.
Oh, I can see.
Yeah, move it.
Tap it, there you go. Straight down, there you go. Yeah. Okay, we're still picking up negative area. So the area graph is still going down, but we're picking up smaller and smaller chunks. And so it's starting to level off. So we definitely saw, okay, switch me back.
Is that all I'm doing? Is just switching back?
That's all you're doing. Well, we'll let you do something else here in a minute. But for right now, just that's all you're doing. So this is concave down, and this is concave up. So, well, that's pretty cool. Yeah, isn't it?
You can only say that like in a calculus class.
Well, I know, but still. But no, I mean, think about this now. Now, see, to me, now listen, the derivative thing, the chart and the derivative thing, the chart was just a way to organize all this stuff, but it wasn't that big a deal in the chart. Okay, Ryan, here, point to whatever I point to, because then when I point here, then the people watching at home can't see it. Okay, so this right here. Okay, this wasn't that big a deal when we were talking about slope. You know, if the slope's negative, the graph's going down. I mean, you learned that in pre-algebra, right? If slope is negative, the graph goes down. If slope is positive, the graph goes up. I mean, that wasn't any big new thing. Now this was, over here, concave up, concave down, that was kind of a new thing. If the slopes are decreasing, they're negative getting more negative, or they're positive and getting less positive, right? That was concave down, concave up. Those were new terms. But again, they were just kind of obvious things from what we already knew about slope. But this thing, this area thing, kind of comes out of nowhere, doesn't it? I mean, the fact that when you look at this area but underneath there, and we've talked all the time about how area and slope might kind of be connected. We did the very first 2 days of class, we did those worksheets that kind of talked about how slope is dividing the y's and x's and area is multiplying the y's and x's. And I mean, there seemed to be some things. We talked about distance. If you had the miles and you did the slope, it was miles per hour. And then we had, if you did miles per hour, did the area under it was miles, right? I mean, so we kind of were seeing this connection. So it's not a huge big deal. But to me, that's really cool. When you look at those areas and you start writing down those connections, and all of a sudden it's the same connections in reverse. So what is the result of this? And to be honest, I've stolen a lot of the thunder from Monday and Tuesday already. But what is the result? The area function is what? The antiderivative. If we go back to the chart, this is like f prime and this is like f, or this is like f and big F, right? I mean, it would seem that area is that connection. And that is really what is how this became a big deal, the connection between those things, between derivative and area, or slope and area, and how those packaged together become this body of work called calculus. So, so that is kind of the main result. Now, we're going to get to see it on Monday in some different forms, like equation form, too. Okay, and see how that all plays together and how we can use that to actually find those areas. I mean, keep in mind that one we had today that was 8/3. You know, where'd that come from? How in the world was that 8/3? And so we'll talk about that. Okay, switch me back to, we're going to go to something different here, Ryan. Go to the one right next to the calculator down there. That one.
That one?
That one, yes. Okay. Now, this is going to challenge you right here. Okay. I want you, down at the bottom left there, it says A, arrow B, right under sweep. Right there, I want you to click that. All right. So, there's the area from A to B. Okay, now that's negative. And as that thing was sliding, so go up, Ryan, to the red dot here. This is going to get interesting. Until it turns, there you go, until it turns horizontal like that. Now click and hold and drag back to the left. Okay, it's not clicking. Back, try it again. Right there, click. Boom.
I can hear the gears burning.
Click. There you go. Okay, so, now slide back to the right. As he slides to the right, see how this is negative and getting more negative, right? And notice the right endpoint is changing. Left endpoint staying still. So this is our input of our area function, and this is our output, which is our area. Okay, go ahead and hit A to C. So now the area is still now going to get more, okay, it's negative, getting more negative, getting more negative, getting more negative. Now it's going to keep going. Now it's getting more negative, but in smaller chunks, and now we're gaining some positive. Now those two positives end up canceling each other out, or the positive and negative. Okay, go ahead and hit reset. Okay, and then do that A to C again. Now, or do A to B. Do A to B. So A to B, what would the area graph be doing right here? Go ahead and hit it again. Decreasing at a Constant rate, because the chunks we're picking up are equal, right? So it's going to be going, so I want you to get this in your mind, and then we're going to show you the graph in a minute. So it's going to be going down, but at a constant rate. Okay, now hit A to C. So from A to C, so now it's going down at a constant rate, and then once we get to B, it's going to do what? It's going to go down at a, it's going to be leveling off, right? Because we're picking up smaller chunks. And then what are we picking up there? Positive and bigger chunks. And so we're concave up, right? Now, look at the green, look at from B to C. It was increasing this whole time. So since it's increasing the whole time, the graph's concave up. First it was negative chunks, but picking up littler negative chunks. Then it was positive chunks and picking up bigger positive chunks, right? So we should have a graph that's coming down in a line, then all of a sudden start leveling, and then coming back up, right? Okay, now go from C to D. Now what's going to happen from C to D? Still going up because you're picking up bigger chunks until where? Till the top. Go ahead and hit C to D again. At the top, we keep picking up chunks of area, but what? Now we're picking up smaller chunks. So what's the graph do? Starting to level off, right? We're going to have an inflection point right there, right? That graph changed from increasing to decreasing, so we're going to change concavity, inflection point. Okay, and then finally from D to E, we're going to be picking up what kind of chunks? Positive chunks, so the graph's going to be going up. It's going to level off, isn't it? At a slower rate, because we're going to pick up smaller and smaller chunks. Okay, so go ahead and right above the reset, hit the reset. Hit reset. Hit reset, there you go. And then hit C graph of integral. Okay, and now go back and hit the A, down to the far left bottom, A to E. Okay, and watch here. Okay, so here we go. We're picking up negative area at a constant rate. And then we start picking it up at B. We start picking it up, but it's starting to level off. And now we're starting to pick up positive area, so the area's going up. And then we're going to keep picking up positive area in bigger and bigger chunks until there. And now we're picking up smaller chunks. And then so it's turning and leveling off. And now we're picking up still smaller chunks. Right? And isn't that like when we did an F prime to an F graph, right? Except when we used to do it, we would do it in terms of slopes, right? We would look at it and say, oh, the slopes are negative, and then the slopes are still negative but getting less negative, right? We would talk about it. How are we doing here? Getting close. We would talk about in terms of slopes. The slopes are positive and getting more positive, or negative and getting less negative, or whatever. And now we're talking about in terms of area. We're picking up bigger chunks of area, littler chunks of area, but we're picking up area. We're picking up negative area, so the area's going down, right? And we end up with the same stuff. Same stuff. Pretty cool. Now, one more thing. I just can't resist. We got to throw in this one last thing. What if we didn't start at point A? What if we changed the left endpoint to something different? Now, have we changed little f at all? Right? Remember, when we went from an F prime graph to an F graph, which is what we're doing, right? What did we know about that? If we went from an F prime graph to an F graph and we went to draw it, what did we know? We didn't know where it started, right? Why not? What do you know about antiderivatives?
Plus C.
Plus C. I want you to watch this graph right here. I want you to hit reset, Brian. We only got 5 minutes. Okay. C graph of integral right above it. Click that. Okay. Now, I want you to hit B to E. Now wait, before you do it, everybody watch this. Okay, hit B to E, go. What happened? Moved up. Because, why? Because B, if B is your left starting point, then the integral from B to B is 0. So your area has to be 0 there. Before we were starting at A, so your area from A to A is 0, so it started right at 0. Now go ahead and hit C to E. Oops. Did it move? Oh, because B and C both have an area 0 because of those two things. Go ahead and hit D to E. Left. There you go. See? It's the same area graph, because those are all the same areas. Now that answers back a little bit your question about what if you went on the other side of it and so forth, because, well, right here, hit E to A right now, right down here. Okay, now, tell me, is the graph decreasing right now? Would we say this graph is decreasing right here? I didn't. This graph, is this graph decreasing right here? When we talk about increasing, decreasing, we're always talking about this way. If we watch the area go this way, this is what gets confusing, we'll talk about next week. When you go this way, you'd say, hey, I'm picking up positive area. No, you're really picking up, because you're going backwards, you're picking up negative area. You say, oh, when you pick up negative area, it's decreasing. But yeah, it's decreasing going backwards. What's that really mean? Increase. See, my head hurts already. We better see. All right. So, but see, now listen, you'll be snowed in tomorrow. There's nothing to do. You can ponder this. You can be thinking about this. Oh, you got it. Oh, well, there you go. So, see, no homework. As long as you got that package.
So would it come out of the way to flip the graph now?
Are you recording all this?
Oh, hey, yeah. Tori, and those of you from First Block, Hannah was gone. So you guys at home, the homework was 1 through 20 on that LH page 289, not the front page, it was the second page, page 289. And that was our homework for Monday. All right. And now I'm going to quit.